would like to present our work on integrating automated analog integrated circuit placer into computer-aided design software. Placement design is a step in the overall circuit design when the schematic is transformed into placement. Schematic, such as in the top right corner, describes the used devices such as transistors and resistors and their interconnectivity, while the placement assigns to each device its position and orientation. The placement needs to satisfy crucial design constraints such as minimum allowed distances between devices, and we need to minimize the circuit's area and approximate length of interconnections. Unlike in the digital case, placement of analog integrated circuits is still not automated due to the presence of complex constraints and is still done mostly manually, which is a time-consuming process. We utilize state-of-the-art cadence design software, which uses skill language to implement potential plugins. We developed a Python-based plugin placer, which uses integer linear programming solver to find a feasible placement, which is then exported back to the cadence environment, as is shown in the diagram. The main input is the netlist, which is a standard format which describes devices, their type, size and connectivity, and can be seen in the top right part of the slide. Additional files describe the used technology, which determines the minimum allowed distances and sizes of so-called pockets around devices, or topology file, which describes higher level structures such as current mirrors. Lastly, user controls parameters of the solver such as coefficients of the objective functions or size constraints on the final circuit's area. In this demo, we can see cadence environment, example schematic, and the pop-up window which controls the placer. User first selects the netlist file for bias FG circuit. Then the user selects the topology file, which groups devices into current mirrors or logic objects when the devices needs to be placed in the regular matrix-like pattern. The cursor highlights which topological structure corresponds to which part of the schematic. User can also adjust coefficients of the objective function or maximum time limit for the solver, or sizes of pockets and presence of dummy devices. The user initiates the optimization. Feasible solution is found and visualization is created. Solution is exported back to the cadence and can be viewed as a layout. We can see the layout corresponds to the previously created visualization. Finally, we can see that additional dummy devices not described by the netlist were also added as per the user's requirement. We can clearly see two regular matrix-like patterns of devices which corresponds to two current mirrors described by topology file. Experiments were already run by ST Microelectronics company. The placer was able to find high-quality solutions in just minutes instead of hours needed in manual case. To show the fine control the user has over the placer, two figures were created. The top figure shows the unconstrained placement, while the bottom figure shows the placement when the user enforced maximum height to 40,000 units.